Welcome to all of you tuning in. We're about ready to start the last session of the day, featuring our guests from Tamer, along with Mathur from Neo4j. A couple of reminders. We will be sending an email with links to the presentations in the next day or so keep an eye out for that. And we are taking questions at the end of the session, so please don't hesitate to ask a question or two using the questions tab located at the top of your screen. If we don't get to your question, you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. And lastly, be sure to post about today's connections using hashtag Neo4j. Without further delay, I'll hand the floor over to Lance Walter, Chief Marketing Officer at Neo4j, to introduce today's final session.
Anthony Deighton is Chief Product Officer at Tamer. Many years ago, Anthony and I actually worked together in product management at Siebel Systems, where Anthony was a general manager. Since then, Anthony really has played a key role in absolutely transforming the analytics landscape. He spent 13 years leading products at Click and helped to upend the traditional business intelligence market and really usher in a new wave of data discovery and self-serve analytics. Anthony holds a Bachelor of Arts degree in Math and Economics from Northwestern University and an MBA from Harvard. And we're very proud to feature a luminary like Anthony on Neo4j Connections. Julia Neagu is Director of Analytics at Tamer. Prior to Tamer, she worked as a senior consultant and a lead data scientist at Aon. Julia brings a lot of intellectual horsepower to our event today. She holds a Bachelor's of Arts in Physics with a minor in Applications of Computing and earned her Master's and PhD in Physics at Harvard. And finally, Nav Mathur, as our head of global solutions, Nav speaks frequently on a lot of interesting topics around industry issues, compliance issues, various graph-powered solutions. He's got a really deep consulting background, having held roles at companies like Wipro, Tata Consulting Services, and Cambridge Technology Partners. Nav has a master's degree in systems engineering from Boston University. Well, to wrap up this connection's really strong, welcome Anthony, Julia, and Nav.
Thank you, Lance. Welcome to the session on Cloud Native Data Mastering for the Enterprise. This is Nav Mathur. I head up solutions at Neo4j. And with me today is Anthony and Julia from Tamer. And I'll let them introduce themselves as they speak. So we have a lot of connected data that is driving innovative solutions like cross-sell, recommendations, customer 360, fraud, whether it be credit fraud or application fraud or anti-money laundering, et cetera. But a lot of the data that these solutions need lies in underlying siloed databases and data stores. So you have a lot of relational databases. You may have systems like SAP or Oracle. You may have data warehouses or data lakes. But a lot of this data is structured today as flat structures in rows and columns. And that needs to be brought into a connected structure like a graph with Neo4j. So that's the first order of business, or the first challenge that we have to overcome to solve for these innovative solutions. And in order to do that, we need a technology that can do that at scale. And that's where Tamer comes in. And so let me introduce to you Julia, who will talk a little bit about Tamer and what they do.
Thanks, Nav, and hello, everyone. My name is Julia Neagu, and I'm the Director of Analytics at Tamer. And I'm very excited to be taking part of Neo4j Connections today. So in 2020, organizations are still struggling to leverage their data as an asset. Many have invested significantly in analytics programs, and the software for BI and analytics visualizations has reached maturity. But the reality doesn't match the vision, and data continues to be the problem. As internal and external sources grow exponentially, throughout the years, companies try to break down their data silos, like Nav just mentioned, with technology like data lakes, warehouses, NDM, and ETL solutions. And unfortunately, all these have failed to bring together data from internal and external sources at the enterprise scale, and actually created some costs maintaining rules. As a result, data-driven projects take years, and many of them fail to get off the ground. This is where Tamer can help. From customer 360 to supply chain optimization, we help leading organizations across the globe solve several business challenges that all tie to that need for timely, accurate information on enterprise data. we support several solutions across industries to help our customers drive business outcomes. And some of those outcomes include improved customer experiences and cross-selling with Customer 360 projects, and driving cost savings through accurate spend analytics and optimizing procurement strategies. So for example, one of our customers leveraged Tamer to master data on suppliers and parts, arming their procurement managers with the data needed to improve negotiations and find over 300 million in cost savings. Today, we will show you an example focused on the financial services industry, and in particular on anti-money laundering, or AML. Tamer provides a wide range of solutions in this space, from reference data management and regulatory reporting to transforming our clients' data into analytics-ready data sets for procurement and spend analytics, and of course, Customer 360. This spectrum of solutions overlaps with the offering of our partner, Neo4j. So a little bit of how Tamer actually works. So Tamer takes some ML-first approach to consolidating disparate data sources to create a unified data model. A key component of Tamer solutions are intuitive feedback workflows that engage data experts through simple yes or no questions to train the machine learning algorithms in a matter of hours, therefore improving data quality and using their time effectively. Afterwards, Tamer cleanses data by deduplicating records and standardizing values. And from there, Tamer enhances business intelligence use case by categorizing data at an extremely granular level, leveraging well-defined taxonomies. And with our seamless data publishing capabilities, our teams can finally trust the completeness and readiness of analytics and data initiatives powered by Tamer, further accelerating their business outcomes. And since we're talking about how Tamer can function with Neo4j, Tamer can, of course, publish its unified data sets directly to a Neo4j database, from which the users can quickly produce accurate analytics and visualization. I wanted to also focus a bit on how our solution compares with the existing solutions in this space. Our approach automates a significant portion of the data mastering process, letting subject matters experts focus on the outliers instead of developing rules for every possible data iteration. The result is accelerated data mastering projects in weeks or months instead of months or years.
Thanks, Julia. I love that automation. I think that is so important to get a huge amount of data in quickly with minimal human input. So I love that about Tamer. And so let's just talk a little bit about Neo4j's graph-based solutions and how we're using Tamer. So Neo4j's graph-based solutions sit on top of our native graph platform that you're very familiar with, probably. And Tamer falls squarely in our data integration layer that you see here. And it helps us ingest all of this data, both at the start, the initial load, but also continuously thereafter as more data comes in. And sitting on top of our native graph platform is our solution frameworks. And what these solution frameworks are a starter package, if you will, that is pretty well vetted with our existing customers and pre-built for you for the most part. So it has a starter data model. It has this data mastering framework for that specific use case that includes all the ingestion logic for the sample data that we have. And the sample data that we have as part of this is large data sets. It's not like a toy problem. We also have lots of business scenarios built in. So the queries behind those business scenarios as well. So when we talk about AML, we'll have different business scenarios like transaction structuring, like connections to high-risk entities or high-risk geos, or the KYC entity resolution type of scenarios are already built in as queries. And then these frameworks automatically provide a canvas for you to build a microservices engine, and it automatically creates those APIs for those engines for you. And then finally, we have a dashboard where you can build all your business logic very easily. and also then visualize those results in terms of a business dashboard and visualization with Bloom that we bring in. Bloom is our visualization tool. We bring that into the application as well. So it's a comprehensive framework, and we have these available for multiple use cases. Here we're going to talk a little bit about our AML specific, but these solution frameworks, as I said, are customizable and the end-to-end customizable. So starting from a data mastering perspective, you can select the type of data you want to bring in. You can customize the algorithms that are used to master the transformations that you want to do. And as I mentioned, we have a starter data model. The starter data model can be customized as well to how your business operates, what entities are important to you for this particular use case. And then we have a processing and analytics layer, which is where you can essentially put in your business logic. Again, we provide a set of starter business logic for you. Those are the business scenarios, the queries behind those business scenarios, as I mentioned, but that can be adjusted and customized to your specific solution and the specific scenarios that you want to use here. And this layer can also score your output so that it can stack rank the output that it's producing. And so it's almost like a prediction or a recommendation that is giving you in terms of AML. It is recommending or analyzing the entities that might be perpetuating those scenarios or laundering money. And then finally, we have our applications and insights layer, which is really where you have your visualizations, your dashboards, and things like that. And obviously that can be customized. We have a sample dashboard that we will show you in the demo, but obviously that is something that's customizable and it's completely driven off of the API that we produce from those engines. So just then in a nutshell, talking about our anti-money laundering solution, at the core, we have this framework is really helping reduce the false positive rate. And we know that banks are having false positive rates as high as 85 to 95%. And a lot of labor and investigation effort, it goes into that and lets a lot of true positives fall through the cracks because of the fatigue with the false positives. And it really helps in supporting compliance and investigations. With that scoring approach, it can really separate out the false positives from the true positives, and then it can help you visualize that. So that really underlying this framework is really our KeyMaker analytics pipeline. This is where you put in all your business rules, as I mentioned, and this really helps to produce these scored scenarios, and the score can be explained as to which scenarios are producing these scores, which is key in understanding what underlying patterns are being executed by the fraudsters underneath with all the data. And that sort of helps the investigator make faster decisions and identification of the different scenarios in play. And all of this, the KeyMaker is really what makes your entire framework perform at scale and makes it all customizable. And then, of course, we have Tamer that is behind the scenes ingesting all the data for us automatically with minimal human input. And it helps to map all the schemas from the source to the target and create those golden records for entities and do all the data transformation needed to create, and it also helps creating a robust data dictionary as well. So, the combination of these three things really makes the solution customizable and be delivered in rapid timeframes. So we can deliver one of these solutions and implement them with the customization in weeks as opposed to months that normally it would take to develop such a solution. And underneath, behind the scenes, we also have a lot of graph algorithms, both on the Tamer side as well as the Neo4j side, that is working behind the scenes to connect these data together, so and identify the connected components in the data. So we have things like PageRank to measure influence, Louvain that detects communities that interact together, and Jacquard that measures similarity. There's other algorithms in play as well, but we have a whole host of algorithms in different categories that Neo4j provides, and as well as Tamer has within their platform to identify duplicates, to identify, to resolve entities and such. So with that, let us now look at the demo and look at some of this in action. Julia, over to you.
Thank you so much, Nav. We'd love now to use this opportunity to do a bit of a hands-on demo of how Tamer and Neo4j can work together. So as I mentioned earlier in the presentation, the power of Tamer comes from the ability to leverage both the knowledge of subject matter experts and the automating powers of AI in unifying data fast and at scale. And this is what I'm hoping to show you today. So in this example that we see here, this is a Tamer instance. This is how you'd see your projects loaded up in Tamer. So in this example, we are mastering two customer data sets. One consists of individuals, so people, and the other one is institutional. So for example, companies. And you can see these two projects right here. So we'll first look at the individual customer mastering. And oops, if I click here, in the datasets tab, the first thing we did was we uploaded the input datasets to a Tamer instance. So data, as we mentioned before, is oftentimes scattered across multiple data sources, which makes it more likely for duplicates and errors to stay undetected, which would make any downstream analysis, or for example, any graph analysis that we might do later, muddy and inaccurate. What Tamer does is it can ingest a wide variety of structured and semi-structured data, from flat files through the UI to relational databases, semi-structured data that I mentioned, JSON or XML files through the Tamer API. In this example, we kept it a bit simple. We have 3 different data sets of customers from different data sources, and you can see those here. We can look now at the schema of this project. And what we did, we started by connecting the data sources and developing a common unified schema such that we can compare similar fields as we try to match the records. And this is how it's loading up a bit. It's taking a little bit to load, but here we go. So this is an overview of how our unified data set would look like. And in this example, we will master individual customers using familiar attributes that we can see here. So we can see the account's name, their email address, their gender. We won't take the gender into consideration, but we will take, for example, the phone number, the street address, and a taxpayer ID when we do our mastering. So what I wanted to show you is a little bit about how we would be training the model, as I mentioned before. So whereas the AI will eventually be able to make decisions about what constitutes and does not constitute a match, first we need to provide with training data by manually comparing pairs of customers to each other and deciding whether or not they're the same or they're distinct. So we could, of course, generate all possible pairs of records, but generally that's not a great idea for performance reasons on any data set that realistically is more than a couple hundred records. So we definitely want to filter down the pairs that we'd be looking at. And the way to do that is by deciding our thresholds for what we could conceivably consider as a match based on relevant attributes. In this example that we see here, we say that we'll only review pairs for individuals whose first names are more than 30% similar, their last names are more than 80% similar, and so on. So once we set up the pair generation rules, we can go and see the pairs that we generated. And in this case, we generated 37,000 pairs, but the good news is that we do not have to label that many in order to get a good mass-trained model. As a subject matter expert, we would go and check the pairs that have been assigned to us as a subject matter expert. And I want to show you in this example a couple of pairs that I thought were interesting for kind of like realistic examples that we may see in our data sets. So looking at Shep-Keddy here, this is how we compared the details of the pair. So in this example, we were actually able to leverage the fact that we enriched our data with geospatial locations for the addresses. So we can actually see that here. So this type of geospatial enrichment can come handy in a situation such as this one. So as we can see here, the customer has similar name and a similar, an identical email address, and also has a pretty similar address here. But when we actually go and look at the geospatial location of those two addresses, we see that they're in completely different parts of the state. So this is a situation in which we might decide that these two entities are not similar enough to be a match. Another example, we have Ansley here, who we can see if we look at the details that one of the versions of this record has a couple of missing information. So it's missing the email address and the phone number. And we might be inclined to say that these two individuals are not the same, especially since the address is different. We can see the actual street address numbers are different. However, when we look at the geospatial location for these addresses, we see that these two individuals live in the same building. So based on the fact that the names are the same and they live in the same building, let's say as a subject matter expert, I can make the decision that these two people are the same. And this is something that we may not have been able to figure out by just doing a string comparison between these two strings, or just by doing an exact match against addresses. Because we would not have been able to figure out that these two locations are in the same building. Finally, I had one more example that I wanted to show you here. We see that Trina also has a nickname, Trin, which they use on one of their accounts. Additionally, in this example, the email addresses are different. One of the accounts is missing a phone number, and there is a slight difference in the street address. And this is an edge case where the SME can actually go into the data and look at these two entities side by side and make a decision whether they believe they're the same entity or not. And this is again something that maybe they'll want to go in somewhere downstream, like in a Neo4j graph, and make that decision later on. But let's say when they're here, they can say this is not a match based on the information I'm seeing right now. So we've done a bunch of pairs mapping here. I've done a little bit advanced, and I already trained the model. And as I mentioned at the beginning, in this case, we were able to get away with not labeling that many pairs. And actually, the model that I built here was developed by labeling only, in this case, 26 pairs out of 37,000. So definitely a very low number of pairs. It happened that I think the data helped us a bit because it was not that messy. So we were able to train them all with a very low number of pairs. I'd say in general, on a regular project, we could label tens of pairs, something like that, maybe like 100 pairs, depending on how messy the data is, but it will definitely be somewhere in that order of magnitude. And with that, I can show you the results of our model. So I want to show you how the results of our model are displayed. So they're displayed as clusters, and a cluster is a set of entities that the AI has identified as matches based on the training data that I just showed you. I want to highlight a couple of them. We can see Stacy Brankley has several nicknames here, maybe even some data entry errors that may have occurred, but all these entities are likely exactly the same person. In particular, when we're looking at the phone number and when we're looking at the taxpayer ID. So this looks like a good cluster. We see that 11 different records were grouped in this cluster. So these otherwise would have showed up as duplicates in, let's say, a customer master list. Another example I want to show you is Haley Elliott. In this cluster, it looks like there might be a potential something that would get flagged in AML type of situation. So we see a potential pseudonym, John S., who has the same address and the same, I believe it was also the same taxpayer ID as Haley Elliott. And this is definitely something that maybe wouldn't have been able to catch if you have done, let's say, an exact match on the name or anything like that. And it's definitely something that got flagged here, and something that we would definitely want to investigate later on. And we also, when we're looking here, we see there are two addresses showing up, but similar to what I showed you in the pairs page, they're in the same building. So again, something that we wouldn't have been able to figure out without having this geospatial enrichment, which definitely comes in handy, and definitely something that we'd want to look into downstream in a more in-depth AML investigation. I also wanted to show you, I mentioned there were two different projects here. So I wanted to show you the institutional customer mastering, where we did a slightly different type of mastering this time, which at this time was at site level. So for example, just to show you a couple of interesting pairs here as well. Here we have Stroman-Dennis, which will actually look more in depth. I think Nav will analyze this a bit more on his end. But here, if we look at the pair, we see that we have different, slightly different taxpayer IDs. So an exact match would maybe not flag these as being the same. In one of the accounts, there's no account holder ID. And there's also some fuzziness in the address and phone numbers. But again, if we go and look at the addresses, so just looking one more time at how the addresses look like. Again, they're different addresses here. We may not be able to get this match lined up if we were just doing a rules-based approach, but here we can again see that they are in the same building. And another similar example here, I mentioned at the beginning that we're doing a site level mastering. That's what we decided to do for the institutions. And we may say that these two addresses are not the same site because they are different street numbers. But for example, if we look here, we see that these two addresses are nearby buildings. So if we were thinking about a company that may have a larger campus, this makes sense. In this case, we might decide to label these as belonging to the same site for this company. And finally, I want to show you a little bit of how the clusters look like. And this cluster will go more in depth in the Neo4j analysis. But I wanted to show you how this looks like in terms of geography. So in this case, we have a couple of different, trying to find them, a couple of different addresses here. And I think we can zoom in a bit. So we see we have a couple of different addresses in downtown here. And again, we may not have been able to figure out that these are nearby or the same address. But we definitely see that despite these addresses being the same, they may be belonging to the same, despite these addresses being like the string of this address being different, they may belong to the same campus. And therefore or to the same business side. And that's why we cluster them together. And again, we see typical fuzziness in the account holder name and the phone number. And in general, in these type of attributes on which we are used to building rules when we don't have something like Tamer to kind of use AI to group these entities together. And one more thing I want to mention, after we do the mastering, what we usually end up doing is build these golden records of the mastered entities. So what golden records are the single source of truth for the entities in our data sets. And we can decide how we want to prioritize the information from different data sources. So for example, if there's a data source that we trust more, we can choose for that, for the data from that data set to take prevalence when building the golden records. But basically, these are built off of those clusters that I just showed you. And these will most likely be what we would visualize as nodes in a graph database downstream. So this is how the mastering would work in Tamer. And what we do from here on is we would export the data to a Neo4j database. And then Nav now can show us a little bit of what we could do in the Neo4j, on the Neo4j side with this type of data for an AML use case.
All right, thanks, Julia. So what I wanted to first share with you is the data model. So what Julia was showing you there in terms of the different entities and she was mentioning a lot of different types of entities. And this is kind of what the model looks like in Neo4j. So you have account holders and their basic demographic information. You have a watch list, politically exposed people, the FATF watch lists, and so on. You have different transactions, different types of accounts, and so on. So it's a pretty comprehensive data model that is part of this framework. And if you go here to the dashboard, this is what this looks like. So you have different types of scenarios, and you're getting some aggregate information on different types of scenarios, like rapid movement of funds in and out of an account, or accumulation of funds, or layered concentration, which is like payment chains that are happening in the data set. And so you can look at these numbers here. For the interest of time, I'm not going to go deep into the AML use case here because the context was really more to show the data mastering aspects and why that is important. But we have different types of transaction-based scenarios that are here, and we can look into the entire database. Let's see here, and look at connections that accounts are having to high-risk geos through transactions, or to people on the watch list. So this would be, if you have transactions that have previously established suspicious activity, that could be a risk factor, and so on. So we can look at the entire database and look at who are maybe suspects with these types of things. So you have Rice, Hudson, and Ward. You can see you have a score. The score comes from connections to high-risk geos and to the watch list. And you have several. And then if you notice here, we have Jaslowski and Sons, which Julia just showed in her data set. And we can see here that they have transactions to the watch list as well. So let's take a look at visually what this looks like, right? And so this is Bloom. This is our visualization product. And you can see We have iframe that in within the application itself, and it can also be popped out. But you can see that it's looking at this query of connections to high-risk geos that Jaslowski and Sons has, and you can see there's a lot of them connecting to a lot of different people with high-risk entities. And then we can also look at this in more detail and see, if we want to look at what is the email on this one, right? And we see this is the email that Jaslowski and Sons has, and then we can further look at expand who else has this email, and lo and behold, we see that there's other Jaslowski and Sons here, right? And this is kind of what you saw in the data that Julia showed inside of Tamer, which got sucked into Neo4j here and connected together. You can also look at other things, like let's look at the business address of this one. And we see that this one has a business address, and this is in Boston, right? And we can look at the business address of these other ones, right? And we see that that's in Little Rock, right? So maybe that's okay. They're all different branches of the same entity. But let's also look at tax numbers and see if that's this is a tax number. Let's look at this one here. We can see they share the same tax number as well. So that's good information, and maybe this is helping us resolve these entities. But also, let's look at the entity resolution side of things, right? And let me just bring over the Jaslowski and Sons ID, which I should have done earlier, so I can look at that specific record here. But here it is. So 58136. So I can go to the entity resolution here, click it to individual, plug that in, and look at if there are shared emails, which we know there were, shared phone numbers. We look at shared tax numbers. We can look at, what if they share any devices and so forth, right? So let's look at this. And what you saw pop up was different parameters that you can plug in as well to narrow the search. So here we see that same account. We can now look at visualize the entity resolution perspective on this. And we see that right here, and we see all those just for Jaslowski and Sons come up. And we can see, in addition to what you saw earlier, we can see they actually also share devices, right? So they are logging in with the same devices into different accounts. So I think that'll help us resolve this entity. And maybe these are not really different accounts, but what one account, and they may be working together and spawning these different entities in different locations to launder money. So we'll have to look at the transactionality of this, and we can actually look back here on the corporate side and go back to Jaslowski and Sons. Sorry, plug in the account number and just look at the transactions and see if that. So we can see that they're doing some transaction structuring as well. And if you visualize that, you will see that there's a lot of transactions that they're working on. that they have with each other as well, right here. So that kind of gives you a clue that there's some perhaps some suspicious activity going on here. So I think the combination of Tamer with some of the resolution that they can do, and also they can enhance the data, so they can add an entity resolution relationship with what they see between two parties, and then we can look at that in the context of the transactions in Neo4j and really resolve, if there is some money laundering behavior that is happening. So the combination of Tamer and Neo4j really helps us to understand the data much better and kind of identify the true positives and get the false positives identified and not necessarily have the investigators waste their time on the false positives. So that was kind of our demo, and I'll hand it over to Anthony to talk a little bit more about Tamer and Neo4j and how the two work together.
All right, thank you, Nav and Julia, for that great presentation. It's really nice to see these two products working so well together. And I think this is a really kind of key idea for where we sit as two organizations, because we really bring the best of each other together to create a really valuable solution in your eyes. And we've obviously shown this in the context of the anti-money laundering use case. But really what it shows is that analytics and visualization alone are meaningless if the underlying data is a mess. And this is something, I've worked in this industry for a long time. It's something I see very over and over again. You've created this beautiful visualization, and then as people dig into the data, they're finding all kinds of errors and problems, and then they lose faith in the meaning of that. And so again, being able to bring these two technologies together give really remarkable analytics and visualization, but on top of the correct data, helps build trust in the organization. It allows Tamer to focus on what it's great at, which is cleaning that data and getting these high resolution entities. And Neo4j can really focus on surfacing that business critical information to the user so they can make the right business decision. And in this context, for example, going after those money laundering use cases. We also work well together as organizations. So how we bring this to market, how we work with you as a customer to think about how we can deploy this to your enterprise. We've created a joint go-to-market strategy so that we can help have this be live and available inside your organization quickly. And last but not least, and in fact, actually last but most important, is in the context of graph data, my view is that this type of data uniquely benefits from cleaning these nodes and connections, and it exposes sort of this hidden truth. And if I sort of dig into this in a little bit more detail, you can look, for example, at some of the examples we might see in a demo where prior to mastering that data, you might have a single node in a graph and see the connections to it. But after you've mastered that data and you've found those duplicate records, now you find out that that node actually collapses a whole series of these nodes. You expose a huge number of connections in that data. So I always talk about this in the context of the relationships in a graph database. When you clean them up, there's exponential value to that because you're exposing these new connections inside your data. And that's one of the reasons we think these two capabilities work so well together. So just to sort of finish off, summarize here, we've talked in this presentation a lot about anti-money laundering and know your customers in the context of the financial services industry. There's a wide range of use cases where the importance of graph data and connection between data can be significantly improved if you take a machine learning based approach to mastering that. So think about regulatory issues or getting a single view of your customer, thinking about your demand and supply chain. We look at relationships between suppliers, supplier risk, also product relationships, and even more generically around commercial analytics as you look for relationships inside your commercial operations. There's a whole wide range of use cases where if we can have clean, normalized, high quality business data at the center of our graph databases, looking at those relationships as this exponential value analytically in terms of the decisions you can make inside your enterprise. So with that, I think we're at the end of our formal conversation. And I believe that we're going to open it up to some Q&A.
Great. Thanks so much, Anthony. That was such a great session to end our day of connections with. So thank you to all for presenting that to us today. I really appreciate it. So now we are going to take some questions from the audience, and I want to remind the audience, you can submit your questions by typing them into the Q&A tab located at the top of your screen. But we have had a few that have come in throughout the session, so we'll go ahead and get started with those. So here's one that asks about Tamer and other ETL tools. Like, how do they work together?
Sure. So Tamer is squarely focused on this challenge of data mastering, and that there are really sort of three components to that. Resolving the question, are these two fields the same field? Are these two records the same record? And categorizing or giving meaning to a given record in a data set. And we use machine learning to drive that process. It's our view that we want to be the most open tool in your data ops infrastructure, and we want to work with all of the infrastructure that you have. And obviously the relationship with Neo4j is front and center in this conversation as it relates to that. But that would certainly be true of other ETL or data movement tools as well. And so we typically find that Tamer works really well in the context of whatever ETL or data movement strategy you already have.
Great, thank you for that clarification. So another one asks about how can they learn more about Neo4j's solution frameworks? Maybe that's for you, Nav?
Yeah, absolutely. So thanks for that question. Yeah, we do have many solution frameworks in the area of supply chain. You saw the fraud and AML here. We have things around privacy, like CCPA, GDPR. We have on human resource management and customer 360, patient journey, and so forth. And you can get in touch with me directly, or my team's email is solutions@neo4j.com, or you can contact sales@neo4j.com, and we can get you more collateral. You can also visit our webpage, and under the use cases, you will find some of that collateral. So there's many ways to get in touch with us, and we'll be happy to give you more information and demos, and we have white papers as well.
Great, thanks, Nav. And this one kind of goes along with that. Someone's asking, how would they engage with Tamer and Neo4j on a specific solution? What would be kind of their entry point to have that conversation?
So I would suggest that anyone interested in a joint solution engage with the account representative that they have from Neo4j or from Tamer, if they know who that person is. And obviously, if you're a Neo4j customer, you probably do. And we'll make that connection. If you don't know who those people are, obviously you can get in touch with anyone on this call. So, Julia, myself, or Nav directly. Use our email addresses there, or just go to our website and express interest there, and we'll make that connection.
Great, thank you. And it looks like we have time for about one more question. So this one, it's asking, are there any scale limitations? I'm assuming that's on the Tamer side.
Sure. That's a great question. Look, routinely, Tamer is mastering data sets that range in the hundreds of millions of records. And we even have a couple of customers in the life sciences industry looking at what's called real world data that have hundreds of billions of records. One of the things Julia pointed out in the demo that's really important is that we spend a lot of time and energy when we think about machine learning at scale, focusing that energy on the most high value questions training that we can give the system. So, even though there may be hundreds of millions or billions of potential matches inside of the data set, what Julia showed is we focus the feedback from the user across the 10, 20, 30, 40 that are most important for improving the efficiency of that model and giving you the best outcome that you can have. And that really helps sort of focus energy on those high value moments. And that helps it scale. So again, we feel pretty comfortable. And I know Neo4j scales fantastically to large data sets, really high performance. So again, these two things work really well together if we can, as we work together on these joint solutions.
Great. Thank you, Anthony. And again, thank you, Anthony, Nav, Julia, for your time today. We really appreciate it. It's nice having you here. For those in the audience, I just want to let you know that you will be receiving an email with links to the decks and the recordings of the sessions. And also just wanted to highlight that our next Connections is coming up on December 17th. That will be featuring the best of Connections 2020. So be sure to mark your calendar for that. You should be receiving an invitation to that event soon. Thank you, everyone. Have a great day and be safe.